We're going to continue talking about variation. This is Algebra II, 8.7b, inverse quadratic variation. If you haven't seen the previous video, 8.7a, or any of the other previous videos, and you become lost or confused, you can click on this description to fill in what you've missed. So back in video 6.9b in Chapter 6 of this playlist, we discussed inverse variation as a functional relationship that can be described by the equation y equals the quotient of k and x, or y times x equals k. And that k is a non-zero, it's a positive constant. Now in the previous video, 8.7a, we talked about direct variation. So if y equals k times x, or y divided by k equals x, then that's direct variation. This is inverse variation. Now we've got it set where y equals k divided by x. So think of it this way. If k is your miles to your grandmother and x is the speed that we drive, it's going to equal how long it's going to take to get to the grandmother. If the grandmother is 120 miles away and we drive 30 miles per hour, well, then it's going to take 4 hours. If the grandmother's 120 miles away and we drive 60 miles per hour, now we're going faster, it's only going to take 2 hours. So it varies inversely depending on this value for x. As this increases, this decreases. See? Inverse means opposite, right? So that's what's happening. It depends on this value in the opposite way. As this goes up, this goes down. See? So inverse quadratic variation, y varies inversely as the square of x. So it's x squared now instead of just x. If there's some non-zero positive number k, such that y equals k divided by x squared. We can also say that these two can be multiplied together to get the k, couldn't we? We could do y times x squared equals k. And the law of gravity states that the weight, w, of an object varies inversely as the square of the distance, d, from the center of the earth. So w equals k divided by d squared. Well, we can use this, and we can find an equation of variation where w varies inversely as the square of d, and w equals 3 when d equals 5. So we just take these values and substitute them into our equation. So here's our equation. We're going to set w as 3 and d as a 5, so we have 5 squared, don't we? So that's going to give us a 25 down here for our denominator. If we multiply both sides of this equation by this 25, the reciprocal of this denominator, we can isolate the k because we get 25 over 25, so that's a 1, and we have k, and on this side we have 75. So our equation is w equals 75 divided by d squared. See? Let's try it again. We can find the equation of variation where y varies inversely as the square of x, and y equals 1/4 when x equals 6. And we just substitute in our 1/4 for y, and our 6 for our x. We got 6 squared, which is a 36. So we can multiply these two together to isolate and find out what k is, can't we? We can do 1/4 times 36 over 1 and get a 9. So we know 9 equals k. Then we can write our equation, y equals 9 divided by x squared. See? Try it one last time with some decimals. So we can find an equation of variation where y varies inversely as the square of x, and y equals 15/100ths, 0.15, and x equals 1/10, 0.1. We substitute in our values for y and x. We get 0.15 equals k divided by 0.1 squared, which is a 0.01 when we do 0.1 times 0.1. Now, we can isolate the k by multiplying these two together, can't we? And 0.15 times 0.01 is 0.0015, so that's the value for k. We can write an equation, y equals 0.0015 divided by x squared. See? Now here's the tricky part. It might get confusing, but if you look at this a couple times and go slow, it'll make sense. If y varies inversely as the square of x, okay? So if this y equals k divided by x squared, x does not vary directly with the square of y. So we can't say x equals k divided by y squared. That's a no-no, all right? We can't do that. So if that comes up in a test or if it's on homework or anything, you know the answer is no. X does not vary directly, okay? We have y varying inversely as the square of x. X does not vary directly, okay? Our next video, 8.7c, we're going to talk about joint quadratic variation. We talked about joint variation before. Now we're going to talk about joint quadratic variation. I'm going to add this video to the Algebra 2 playlist. Back in Algebra 1 last year, we covered inverse variation in 12.6a and 12.6b. This introduced it. This had some problems about it. And this is also going to have links in this description to 6.9b, where we first talked about inverse variation in this playlist, and all those links to Chapter 8 videos, those 12 previous videos for this chapter. All right? So really pay attention to what we talked about in the last video with direct variation, and this video, inverse variation. This one, as x goes up, y goes down, doesn't it? And it could even be as written as y times x equals k, couldn't it? So it's not just y equals k divided by x. We could even write it like that, couldn't we? Okay? So keep that in mind. All right. I hope you have a great day, and I'll see you next video. Bye.